Hello, Craig Hartman for VFDs.com. Today we're going to talk about motor nameplates. Let's take a close look at a nameplate here. Now let's take a look at a 300 horsepower motor, and if we get close to this motor you can see where the nameplate is mounted on that motor. Here's another motor. This one is a 400 horsepower motor. Both of these are three-phase industrial induction motors, and you can see where the motor nameplate is on this motor. Okay, now let's take a look at a three-phase induction motor, heavy-duty motor, specifically constructed for use with variable frequency drives. Now this particular motor, you'll notice that we've cut a section out with a bandsaw so that you can see what the inside of the motor looks like. This outside, the part that is static, is called the stator, and this part on the inside that turns is called the rotor. Now let's turn this motor around, and you can see the motor nameplate. Now let's zoom in on this motor nameplate and let's talk about the various features of that motor nameplate. This motor on the right hand side on the top, you can see that it's suitable for use in the US or in Canada. It has the CSA sticker, but it's also built to UL standards. The middle has the manufacturer's name. And then over on the left, you can see that this is a motor that's specifically built for variable frequency drives. It's a premium severe duty motor. And the first thing we see is that it can take a 10-to-1 speed range on variable torque. In other words, a variable torque load like a fan or a pump, you can run this over a 10-to-1 speed range from 10% speed to 100% speed. On constant torque loads like a conveyor or an elevator, it has a 4-to-1 speed range, which means that you can run it from 25% to 100% at full load without overheating the motor. And you can see to the left it says inverter duty. It's very important when you purchase a motor that you get one that specifically says that it is an inverter duty motor. Now let's take a look at some of the other items on this motor nameplate. The first thing to realize is that all motor nameplates are not the same. Each manufacturer will have different items on their nameplate, but some of the pieces of information on this nameplate are specifically required by the National Electrical Code, and so this motor nameplate will have the required information plus some of the others. On the right hand side you can see you can hook this up for either 460 volts or 208 230 volts. If you hook it up for 460, that's the high voltage connection. If you hook it up for 208 or 230, that's the low voltage connections, and that shows you how to connect the leads. In the upper left, we have the model number. That's specific to the manufacturer. To the right of that is the type. This is TEFC, which stands for totally enclosed fan cooled. This is a heavy duty motor for industrial applications. It's totally enclosed, so it protects it from contaminants, and it is fan cooled. There is a fan on the motor shaft that will enable you to cool that motor. If you look at this motor, this is a totally enclosed fan cooled motor, so you can see that the interior is totally enclosed, and there is a fan back here on the shaft. So as the shaft turns, the fan will rotate, and that fan will push air up and over this cast iron frame. So this is a very heavy duty construction for an inverter duty motor, and it is totally enclosed fan cooled. Back to the motor nameplate, it says code G. That tells you how many amps the motor draws when you first energize it. Now this is appropriate if you have an across-the-line contactor, but on a variable frequency drive this means nothing. On a variable frequency drive, motor never starts. It doesn't have that high current when you start it. Variable frequency drives, the minute the motor starts turning, it's already running. The next line we have the efficiency. That tells you that 95.4% of the energy you put into this motor will come out of the shaft and do useful work. The power factor is 0.9 or 90%, and that tells you about the VARs that you're going to need and about how efficient this motor is in terms of VAR usage. The service factor is 1.25. Service factor tells you that this particular motor can operate at 25% above its rated current for temporary cycles. Now, motors sometimes are rated 1.0, 1.15, or 1.25. 1.15 is the minimum that you'd like to see on an inverter duty motor. And while it is a 1.15 service factor motor, that service factor is used up in the extra heating that occurs in the motor and the fact that you get less cooling as the fan in the motor slows down, and therefore motors on variable frequency drives should not be run above their 100% rating. It's a three-phase 60-cycle motor. It's a 75 horsepower motor. The RPM is 1780 RPM. That is the RPM that you would get in the United States on a 60 hertz power source. If you change the frequency, that RPM will change. The ambient is 40 degrees C. That means that if the temperature around the motor is hotter than 40 degrees C or 104 degrees Fahrenheit, then you will have to derate this motor. Next on that is continuous duty. That tells us that we can run this motor continuously. There are some motors that are only rated for duty for 5 minutes or for 15 minutes because it's the applications that they're on. The insulation class is class F. You generally want to look for an insulation class of either F or H, and that tells you the temperature that the insulation in that motor is rated for. The next one over is your frame size. The frame size is 365T. This is a NEMA frame size. NEMA has standardized on these frame sizes. So 36 tells you that from the base of this motor to the middle of the shaft, it's 36 1/4 of an inch. And then the 5T tell you more about the mounting dimensions. It is a design B motor. That means that the torque curves looks a certain way, and a design B motor is your standard motor design. Now this motor, you can hook it up for 208 volts or 230 volts, which is the same, or you can hook it up for 460. If you hook it up for 208 volts, the full load amps is 180. If you hook it up for 230 volts, the full load amps is 166. And if you hook it up for 460 volts, the full load amps is 83. If we look down further, we have 50 hertz designations because this motor can operate also on a 50 hertz power supply. To the right of that, we have the lubrication. It's very important on a motor that you put in the proper lubrication. You put in the wrong lubrication and it will destroy the bearings. And finally, we have the bearing number. Manufacturers have different bearing numbers, and therefore you're going to check with the manufacturer to figure out what type of bearing that is and what the bearing dimensions are. This is generally quite easy with search engines these days. You can simply look up the bearing designation on the internet. So there's the various factors in a motor nameplate. The most important ones are these. You need to know the voltage and the frequency. So this is a motor that is rated for various voltage, but we'll assume 460 volts. We'll assume that's what we're going to run it on and hook it up as, and 60 cycles. When you program your variable frequency drive, you're going to want to make sure that you program into the variable frequency drive the rated voltage and the rated frequency so that it can know how to run that motor with the correct volts per hertz and the correct flux. And then the most important one is the full load amps. So if we hook this up at the 460, the full load amps are 83, and you want to make sure that you program your variable frequency drive to trip at 83 amperes because that is the full load current. So you are going to get full torque at 83 amperes, you'll get half torque at half that amount of amperes, and anything over 83 amperes, it's in an overload. If you're more interested in overload readings, please check out our YouTube video on that. So we've gone through the motor nameplate very quickly. A good place to follow up would be to check out our website at vfds.com, which has a much more detailed description of each of the individual items on this motor nameplate. Or feel free to check out our other educational videos on our YouTube channel, or if you'd like, call one of our knowledgeable specialists at vfds.com.